Imagine waking up to the news that a single place in America could change life on Earth forever. Not because of war, not because of an asteroid, but because of something hidden beneath one of the country's most beautiful national parks. Every year, millions of people walk across Yellowstone's trails without giving the ground beneath them a second thought. They come for the geysers, the wildlife, and the breathtaking landscapes. Children laugh as Old Faithful erupts. Families pose for photos beside steaming hot springs. It feels peaceful. Almost too peaceful. Because nearly 3 miles beneath the surface lies one of the most closely monitored volcanic systems on Earth. For decades, Yellowstone has inspired terrifying headlines. Every earthquake swarm, every rising hillside, every unusual geyser eruption seems to trigger the same prediction. This is it. The supervolcano is waking up. Some believe an eruption would plunge the planet into darkness. Others argue the threat has been exaggerated beyond recognition. So who's right? The answer isn't as simple as yes or no. Because there really was a time when Yellowstone behaved in ways that made scientists stop and pay attention. The ground began to rise. Hundreds of earthquakes shook the park. Instruments detected changes deep beneath the surface. Around the world, panic spread faster than the facts. For a brief moment, it seemed as though humanity's greatest volcanic nightmare might be unfolding. But the deeper scientists looked, the stranger the story became. This isn't the story of the day Yellowstone almost destroyed the world. It's the story of how one place exposed the difference between fear and reality. To understand why Yellowstone terrifies so many people, you have to forget everything you think you know about volcanoes. Most volcanoes announce themselves with towering mountains, snow-covered peaks, rivers of lava flowing down steep slopes. Yellowstone has none of those. You can stand in the middle of it, look in every direction, and never realize you're standing inside one of the largest volcanic systems on the planet. That's because Yellowstone isn't a mountain. It's a scar. More than 2 million years ago, an eruption so powerful emptied an enormous reservoir of magma beneath the Earth's crust. As that underground chamber collapsed, the land above sank with it, creating a massive depression nearly 45 miles across. Today, forests, lakes, rivers, and wildlife cover that ancient collapse, hiding one of the most extraordinary geological systems on Earth. But Yellowstone never truly went quiet. Heat from deep below still powers thousands of geysers, bubbling mudpots, steaming vents, and brilliantly colored hot springs. Nearly half of all the geysers on Earth exist within this single national park. Every plume of steam is a reminder that the Earth's interior is still alive. And that's exactly what makes Yellowstone different. Unlike an extinct volcano, Yellowstone is active, not erupting. Active. The distinction matters. An active volcanic system is always changing. The ground slowly rises and falls. Earthquakes ripple through the crust. Underground water shifts direction. Pressure builds, releases, and builds again. Most of these changes are completely normal. The problem is that normal geological activity can look terrifying if you don't know what you're looking at. And in the early 2000s, Yellowstone began changing, just enough to convince millions of people that something catastrophic was about to happen. The question was no longer whether Yellowstone was alive. It was whether those changes meant the countdown had already begun. The fear surrounding Yellowstone didn't begin with science. It began with imagination. Long before the internet, long before viral videos and disaster movies, Yellowstone was simply a mystery. Early indigenous peoples had lived alongside its steaming valleys for thousands of years. They knew the land was unusual, but they saw it as part of a living world, not a countdown to the apocalypse. Then came the explorers. In the late 1800s, they returned with stories so unbelievable that many people dismissed them as fiction. Rivers that seemed to boil, pools glowing in shades of blue, orange, and emerald green, jets of water exploding from the ground with astonishing precision. Then the photographs arrived. Suddenly, the impossible had proof. Yellowstone became the world's first national park, celebrated as a natural wonder unlike anything on Earth. But beneath its beauty, scientists slowly uncovered something far more astonishing. Layers of volcanic ash, scattered across much of North America, all pointed back to the same place. Yellowstone. The evidence revealed that this landscape had experienced not one, but 3 colossal eruptions over the past 2.1 million years. These weren't ordinary eruptions. They were among the largest known in Earth's history. That's when a single word changed everything. Supervolcano. Scientifically, it was simply a way to describe an eruption of extraordinary size. But outside the scientific community, the word took on a life of its own. News outlets loved it. Hollywood embraced it. The internet turned it into a legend. Before long, Yellowstone wasn't just a national park anymore. It became the volcano that people believed could end civilization. And every time the earth moved beneath it, that legend grew stronger. For decades, Yellowstone appeared calm. Tourists filled the boardwalks. Old Faithful erupted on schedule. Wildlife roamed the valleys as if nothing unusual was happening. But hidden across the park, dozens of scientific instruments were watching a different Yellowstone. One that never stopped moving. GPS stations measured the ground with incredible precision. Satellites tracked tiny changes from space. Seismometers listened to vibrations deep beneath the crust. Then, in the early 2000s, the data began telling an unexpected story. The floor of the Yellowstone caldera was rising. Not by a few millimeters. In some places, it lifted nearly 10 inches over just a few years, one of the fastest rates ever recorded in the park. Then came the earthquakes. Not one massive quake. Hundreds. Sometimes thousands. Instead of a single powerful shock followed by aftershocks, Yellowstone experienced earthquake swarms. Clusters of smaller quakes that appeared, intensified, then disappeared, only to return somewhere else. To scientists, it was unusual. To the public, it sounded like a warning. The headlines wrote themselves. America's supervolcano is waking up. Television specials showed computer animations of ash covering continents. Online videos predicted global extinction. Social media amplified every rumor until speculation began to sound like certainty. The evidence seemed impossible to ignore. The ground was rising. The earth was shaking. Steam vents were changing. Surely, something enormous was building beneath the surface. But there was one problem. The data wasn't pointing toward the disaster everyone imagined. In fact, the more scientists investigated, the more they realized they were witnessing something far more complex than a volcano preparing to erupt. They were watching a living planet, doing what it has always done. By the end of the 2000s, Yellowstone was no longer just a geological wonder. It had become one of the most feared places on Earth. Every new earthquake swarm triggered another wave of panic. A slight rise in the ground became breaking news. A change in a geyser's behavior became evidence that an eruption was only days away. The internet did what it does best. It filled the gaps with certainty. Videos claiming Yellowstone was about to blow racked up millions of views. Dramatic maps showed North America buried beneath ash. Some predicted the collapse of global agriculture. Others claimed humanity would never recover. The more terrifying the prediction, the faster it spread. Meanwhile, scientists were experiencing a different kind of pressure. Every unusual reading from Yellowstone Observatory was dissected by news outlets, looking for the next alarming headline. Researchers found themselves answering the same question over and over. Is the eruption about to happen? Their answer was almost always the same. We don't see evidence that an eruption is imminent. But calm explanations rarely go viral. Fear does. And then, just as public anxiety reached another peak, Yellowstone delivered its largest earthquake swarm in years. Over the course of weeks, hundreds of earthquakes rattled the region. Instruments detected the movement instantly. News organizations rushed to publish updates before scientists had finished analyzing the data. To millions of people watching from around the world, it looked like the first domino had fallen. Surely this was different. Surely this time, the warnings were real. But beneath the surface, the Earth was telling a much more complicated story. The very signals people feared most were also the clues that would help scientists uncover what Yellowstone was actually doing. And once they understood it, one of the biggest myths about the supervolcano began to fall apart. The breakthrough didn't come from one discovery. It came from thousands. Every earthquake, every satellite image, every GPS reading became another piece of an enormous puzzle hidden beneath Yellowstone. When scientists combined decades of data, the picture that emerged looked nothing like the one portrayed in disaster movies. The first surprise was the magma itself. Most people imagine a giant underground lake of molten rock, waiting for enough pressure to explode. That's not what Yellowstone looks like. Instead, researchers found an enormous network of hot rock containing scattered pockets of molten material. Much of the underground system is solid. Only a relatively small percentage is actually liquid. And those molten regions are spread throughout the crust rather than stored in one massive chamber. That matters, because a volcano cannot produce a catastrophic eruption simply because magma exists beneath it. The magma must accumulate, become sufficiently molten, and generate enough pressure to move upward through the crust. Yellowstone wasn't showing those signs. The rising ground that had alarmed so many people was more likely caused by fresh magma entering deeper parts of the system. Heating underground fluids, and gently inflating the surface. The earthquake swarms told a similar story. Many weren't driven by magma forcing its way upward. They were caused by shifting faults and superheated water moving through fractures in the rock, perfectly normal behavior for one of the world's largest hydrothermal systems. In other words, the evidence that fueled global panic was also evidence that Yellowstone was functioning exactly as an active volcanic system should. It wasn't waking up. It had never been asleep. That realization changed everything. Because once scientists understood how Yellowstone behaves on an ordinary day, they could finally ask a more important question. If the geology wasn't creating the fear, then what was? The greatest force shaping Yellowstone wasn't magma. It was the human imagination. For thousands of years, our survival depended on expecting the worst. If our ancestors heard something moving in the dark, assuming it was dangerous, kept them alive. The few who ignored possible threats often didn't get a second chance. That instinct never disappeared. It simply found new things to fear. Today, instead of predators hiding in tall grass, we worry about invisible dangers: viruses, asteroids, artificial intelligence, and supervolcanoes. Yellowstone fits perfectly into that list, because it combines two things the human brain struggles to process: immense power and uncertainty. Psychologists call this the availability heuristic. When we repeatedly see dramatic images or hear terrifying stories, our brains begin to treat them as likely, even if they're incredibly rare. That's exactly what happened with Yellowstone. Hollywood imagined continents disappearing beneath volcanic ash. Television specials counted down to global catastrophe. Social media rewarded the boldest predictions, not the most accurate ones. The result was predictable. 1,000 calm scientific reports could be erased by one viral video titled, "Yellowstone is about to erupt." Because fear is emotional, evidence is not. But Yellowstone reveals something even deeper about us. We don't just fear disasters, we're fascinated by them. We binge-watch documentaries about extinct civilizations. We read about shipwrecks, pandemics, and collapsing empires. Somewhere deep inside us is a need to understand the forces that could end everything we've built. Not because we want them to happen, because we want to believe we can see them coming. And that belief creates a dangerous illusion. That every strange event must be a warning. That every earthquake must have a hidden meaning. Nature doesn't work that way. And Yellowstone was about to prove it once again. Here's the irony. The danger most people feared was never the one most likely to affect them. While the world obsessed over a supereruption, Yellowstone was quietly reminding visitors that its greatest hazards already existed, and they had nothing to do with civilization-ending explosions. The park is constantly changing. New steam vents appear without warning. Old geysers suddenly stop erupting. Boiling water carves new pathways through the ground, reshaping the landscape one season at a time. Then, in 2018, something unexpected happened. A brand new thermal vent opened near a well-traveled road. There was no dramatic explosion, no rivers of lava, no ash cloud darkening the sky, just steam. The Earth's heat had found a new path to the surface. It was a powerful reminder that Yellowstone isn't a dormant volcano waiting for permission to wake up. It's an active hydrothermal system evolving every day. Scientists have discovered enormous craters scattered throughout the park, carved not by volcanic eruptions, but by hydrothermal explosions. These occur when underground water becomes trapped under immense pressure, superheats, and suddenly flashes into steam with explosive force. The blast can launch massive rocks hundreds of feet through the air. It happens without lava, without warning, without the Hollywood spectacle. For the people standing nearby, it's far more dangerous than the supereruption everyone worries about. That's the twist. The catastrophe dominating headlines is extraordinarily unlikely within our lifetime. The real hazards are smaller, quieter, and already happening. Yellowstone doesn't need to erupt to remind us how powerful it is. It does that every single day. And the more scientists uncovered, the clearer one truth became. The real story of Yellowstone was never about predicting the end of the world. It was about understanding a planet that never stops changing. After decades of research, scientists reached a conclusion that surprised almost everyone. Yellowstone isn't dangerous because it's unpredictable. It's dangerous because people assume unpredictability means catastrophe. The truth is far more nuanced. Every year, the park experiences thousands of tiny earthquakes. The ground rises in some places and sinks in others. Geysers change their timing. Hot springs shift color as microscopic organisms respond to changing temperatures. Deep underground, heat, water, gas, and rock are locked in a constant cycle of pressure and release. To most people, those sound like warning signs. To volcanologists, they're signs of a healthy, active system. In fact, Yellowstone would be more concerning if it suddenly became completely quiet? A living volcanic system is supposed to move. It's supposed to release energy in small ways. Those countless tiny adjustments help prevent pressure from building unchecked. Then comes the biggest misconception of all. People often ask, is Yellowstone overdue? But volcanoes don't follow calendars. The three largest eruptions occurred roughly 2.1 million, 1.3 million, and 631,000 years ago. At first glance, those numbers seem to suggest a pattern. They don't. Geological events don't happen on schedule. They depend on countless conditions deep beneath the Earth's surface. Conditions that scientists continue to study, but cannot reduce to a simple countdown. That's the big reveal. Yellowstone isn't a ticking time bomb. It's one of the most closely monitored natural laboratories on Earth. Every new measurement makes predictions more accurate. Every earthquake teaches researchers something new. Every year without an eruption provides more data to understand the one that will eventually happen, whether that's thousands of years from now or far beyond. In trying to predict Yellowstone's future, humanity ended up discovering something even more important: how to read the language of a living planet. When people leave Yellowstone, they usually remember the geysers, the hot springs, the wildlife, the silence. What they don't realize is that the ground beneath those memories is still moving, not dramatically, not dangerously, just patiently. Long after today's headlines are forgotten, Yellowstone will continue its slow rhythm. Water will seep through cracks in the rock. Heat will rise from deep within the earth. The caldera will lift, settle, and breathe, just as it has for hundreds of thousands of years. And one day, whether it's 10,000 years from now or 100,000, the volcano will erupt again. Not because it's angry, not because humanity failed to stop it, but because that's what living planets do. Perhaps that's the most humbling lesson Yellowstone has to offer. We spend so much of our lives trying to control the future. We forecast economies. We predict elections. We model the climate. We build stronger cities and smarter machines. Yet beneath one of the most visited national parks on Earth, nature quietly reminds us that some forces operate on timescales so vast, they make human history feel like a single heartbeat. Maybe that's why Yellowstone captivates us. It forces us to confront a truth that's easy to forget. The Earth doesn't exist for us. We exist on it. The real story was never about a volcano that almost exploded. It was about the extraordinary world hidden beneath our feet, a world that has been shaping continents long before the first human took a breath, and will continue long after we're gone. The next time you hear someone say Yellowstone is about to destroy the world, remember this. The greatest discovery wasn't that the supervolcano might erupt someday. It was realizing that understanding nature is far more powerful than fearing it. And sometimes, the most dangerous thing beneath the surface isn't the volcano. It's the stories we tell ourselves about it.